Hello students, this is next lecture for Business Statistics second paper TY students. Name of the topic is Poisson distribution as a limiting form of binomial distribution. We have to see examples and problems based on this topic. Poisson distribution as a limiting form of binomial distribution. Suppose X follows binomial distribution with parameters n and p. If n is very large and p is very small, then X will follow Poisson distribution with lambda is equal to np. Now very large means if n is greater than 20 and p is very small, then we can apply this limiting form of binomial distribution. See the example. If 3% of the electric bulbs manufactured by a company are defective, find the probability that in a sample of 100 bulbs, 4 bulbs will be defective. So let X denote number of defective bulbs. See, bulb is defective, bulb is not defective. So it's a Bernoulli trial. So the problem is based on binomial distribution. Then we will recognize the parameters. So X follows binomial with n is equal to 100 and p is equal to 0.03 because 3% are defective. So probability of success is 0.03. So n is 100. So as n is very large and p is very small, X will follow Poisson distribution with lambda is equal to np. Therefore, X follows Poisson distribution with lambda is equal to 100 into 0.03. So we can say that X will follow Poisson distribution with lambda is equal to 3. After getting the parameter, we will write the probability mass function of Poisson distribution as probability X is equal to e raised to minus lambda raised to x upon x factorial. The range of x is starting with 0 and we do not have any upper bound and equal to 0 otherwise. Now replace the parameter. Probability x is equal to x is given as e raised to minus 3 raised to x upon x factorial. And we want to find probability x is equal to 4. So we can calculate this as e raised to minus 3 raised to 4 upon 4 factorial, which is nothing but 0.0497870 into 81 upon 24. So the answer is 0.168081. Next example. A rare blood group occurs in only 1% of the population distributed at random. What is the probability that at least one person in the random sample of 100 has blood of this group? Now the person will have blood of this group, person will not have blood of this group. So it's a Bernoulli trial. So we can say that let X denote number of persons having rare blood group and X follows binomial distribution with n is equal to 100 and p is equal to 0.01 because 1% people have blood group of this particular group, rare blood group. So as n is very large and p is very small, X will follow Poisson distribution with lambda is equal to np. So X follows Poisson distribution with lambda is equal to 100 into 0.01. So we can say that X follows Poisson distribution with lambda is equal to 1. The probability mass function of Poisson distribution is given by probability X is equal to e raised to minus lambda raised to x upon x factorial. The X range starts with 0 and we do not have any upper bound because it is countably infinite and equal to 0 otherwise. So probability x is equal to x is given as e raised to minus 1 raised to x upon x factorial. We want probability x greater than or equal to 1, which we cannot calculate directly. So we will take the complementary event as 1 minus probability x is equal to 0. So to get probability x is equal to 0, we have to write e raised to minus 1, 1 raised to 0 upon 0 factorial. The answer is 0.367879. So probability x greater than or equal to 1 can be written as 1 minus probability x is equal to 0. So which is nothing but 1 minus 0.367879. So the answer comes out to be 0.632120. Next example. Suppose on an average, one house in 1000 in a certain town has a fire during a year. If there are 2000 houses, what is the probability that exactly 5 houses will have a fire during a year? So see, the house will have fire, house will not have fire. So it's a Bernoulli trial. So we can apply binomial distribution. Now we will recognize the parameters of binomial distribution as, first of all, define x. The question part should be my definition of x. Having fire is my success according to this question. So let x denote number of houses having fire during a year. X follows binomial distribution with n is equal to 2000 and p is equal to 1 upon 1000. So as n is very large and p is very small, x will follow Poisson distribution with lambda is equal to np, which is equal to 2000 into 1 upon 1000. So therefore x follows Poisson distribution with lambda is equal to 2. The probability mass function of Poisson distribution is given by probability x is equal to e raised to minus lambda raised to x upon x factorial. Range of x starts with 0 and we do not have any upper bound, and equal to 0 otherwise. So probability x is equal to 0 is given as e raised to minus 2 raised to x upon x factorial. And we want to find probability x is equal to 5, which is equal to e raised to minus 2 raised to 5 upon 5 factorial, which can be written as 0.133352 into 32 upon 120. So the answer is 0.0360894. Next example. In an area, one village in every 500 is raided by ducats during a year. If there are 750 villages in the district, what is the probability that, first part of the problem, exactly 3 villages will be raided by ducats. Second part of the problem, no village will be raided by ducats during a year. So village will be raided, village will not be raided. So it's a Bernoulli trial. So we can say that x is nothing but binomial random variable. So let x denote number of villages raided by ducats during a year. Now we will recognize the parameters in the second step. X follows binomial distribution with n is equal to 750 and probability p is equal to 1 upon 500. So as n is very large and p is very small, x follows Poisson distribution with lambda is equal to np, which is nothing but 750 into 1 upon 500. So therefore x follows Poisson distribution with lambda is equal to 1.5. The probability mass function of Poisson distribution is given by probability x is equal to e raised to minus lambda raised to x upon x factorial. X takes value 0, 1, 2, 3 up to infinity and equal to 0 otherwise. So probability x is equal to x. After replacing the parameter, we are getting it as e raised to minus 1.5, 1.5 raised to x upon x factorial. We are expected to find probability x is equal to 3, which can be written as e raised to minus 1.5, 1.5 raised to 3 upon 3 factorial. So this is equal to 0.223130 into 3.375 divided by 6. So the final answer is 0.125510. Next part of the problem, probability x is equal to 0 can be written as e raised to minus 1.5, 1.5 raised to 0 upon 0 factorial. The answer is 0.22313016. Next example. Records show that the probability is 0.00002 that a car will have a flat tire while driving over a certain bridge. Use the Poisson probability distribution to determine the probability that among 20,000 cars driven over the bridge, not more than one will have a flat tire. So car will have flat tire, car will not have flat tire. It's a Bernoulli trial. So x is a binomial random variable. Let x denote number of cars having flat tire while driving over a bridge. Now we will recognize the parameters. X follows binomial distribution with n is equal to 20,000 and p is equal to 0.00002. So as n is very large and p is very small, x will follow Poisson distribution with lambda is equal to np, which is equal to 20,000 into 0.00002. So therefore x follows Poisson distribution with lambda is equal to 0.4. The probability mass function of Poisson distribution is given by probability x is equal to e raised to minus lambda raised to x upon x factorial. X takes value 0, 1, 2, 3 dash 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 and equal to 0 otherwise. So next step, we will replace the parameter as probability x is equal to x is given as e raised to minus 0.4 in 0.4 raised to x upon x factorial. We want to find probability x less than or equal to 1. So that is nothing but probability x is equal to 0 plus probability x is equal to 1. Probability x is equal to 0 is equal to e raised to minus 0.4, 0.4 raised to 0 upon 0 factorial. The answer is 0.670320046. And probability x is equal to 1, the answer becomes e raised to minus 4 into 0.4 raised to 1 upon 1 factorial. So we will multiply this value with 0.4. So the answer becomes 0.26812818. So probability x less than or equal to 1 can be written as 0.670320046 plus 0.26812818. So the total becomes 0.938448. Next example. Find the probability that at most 5 defective bolts will be found in a box of 200 bolts if it is known that 2% of such bolts are expected to be defective. So bolt will be defective, bolt will not be defective. Again, it's a Bernoulli trial. Let x denote number of defective bolts in a box. So x will follow binomial distribution with n is equal to 200 and p is equal to 0.02. So as n is very large and p is very small, x will follow Poisson distribution with lambda is equal to np, which is equal to 200 into 0.02, which is equal to 4. Therefore, x follows Poisson distribution with lambda is equal to 4. So the probability mass function of Poisson distribution is given by as probability x is equal to x is equal to e raised to minus lambda, lambda raised to x upon x factorial. X takes value 0, 0, 1, 2, 3 onwards and equal to 0 otherwise. Replace the parameter. Probability x is equal to x is given as e raised to minus 4, 4 raised to x upon x factorial. Now probability x less than or equal to 5 we have to find, which is nothing but probability x is equal to 0 plus probability x is equal to 1 plus probability x is equal to 2 plus probability x is equal to 3 plus probability x is equal to 4 plus probability x is equal to 5. Now we have to find all these 6 values. Let's find the first value, probability x is equal to 0, which can be written as e raised to minus 4, 4 raised to 0 upon 0 factorial. The answer is 0.018315638. Then probability x is equal to 1 can be written as e raised to minus 4 into 4 raised to 1 upon 1 factorial. So the answer becomes 0.018315638 into 4, which is equal to 0.073262555. Then probability x is equal to 2 is given as e raised to minus 4, 4 raised to 2 upon 2 factorial. So e raised to minus 4 multiplied by 16 upon 2. So multiplied by 8 we can say. So the answer becomes 0.14652511. Then probability x is equal to 3 is written as e raised to minus 4, 4 raised to 3 upon 3 factorial. And the answer is 0.195366814. Then probability x is equal to 4. Replace the value in the probability mass function. It becomes e raised to minus 4, 4 raised to 4 upon 4 factorial, which is given as 0.018315638 into 256 divided by 24. So it becomes 0.195366814. So, and probability x is equal to 5. That can be written as e raised to minus 4, 4 raised to 5 upon 5 factorial. So answer is 0.018315638 into 1024 divided by 120. So it becomes 0.156293. Now we have to find probability x less than or equal to 5. Which is given as 0.0183156 plus 0.073262 plus 0.146525 plus 0.195366 plus 0.195366 plus 0.156293. So the total becomes 0.785128 051.